Alright, the purpose of this video is to just show you how to solve these problems, and then you can finish the optimization by yourself. Okay, Ex2D, question 1. The sum of two positive numbers is 10. Find the numbers if their product is a maximum. So the thing I'm trying to maximize is the product. So I'll let P be the product. Okay, and I'm trying to optimize the product of two numbers. So I'll let X be one number, and I'll let Y be the other number. My goal is to maximize the product, so I need to write a formula for the product. Okay, the product of two numbers, product means multiplies, will be XY. I can't optimize this because it has two variables in there, so I'm going to try and find some other relationships between these two variables. Okay, I've got this fact at the top line: the sum of the two positive numbers is 10. So I know that X plus Y equals 10. I want to somehow use this information to get only one variable in my equation for product. I'll rearrange so that I get Y equals 10 minus X, and then I can substitute Y equals 10 minus X into P equals XY. Where P equals X. Instead of writing Y, I'm going to write 10 minus X. From here, I can expand these brackets to make the function look a little bit neater. And now I can maximize the product by finding the stationary points. Stationary or turning points, which will occur at P dash of X equals 0 or dP dx equals 0, depending on your notation. Alright, on to question 2. Similar sort of question. The sum of two positive numbers is 8. Find the numbers if the sum of the cube of one and the square of the other is a minimum. So this thing that I've underlined is the quantity that I'm trying to optimize. I'm going to say let S be the sum of the cube of one and the square of the other. Again, we're dealing with two numbers. Let X be the first number, and we'll let Y be the second number. I'm going to write my formula now for S. Okay, S is the sum of the cube of 1. So I'm adding two things together. I'm adding the cube of one number, so the cube of this number, plus the square of the other, plus the square of the other number. You might think, how do I know which way to put them, X or Y? It doesn't really matter. Say the solution was that the two numbers are 5 and 7. If you have them one way, you'll get X equals 5, Y equals 7. If you have the equation the other way, so Y cubed and X squared, you'd get Y equals 5 and X equals 7, but you'd still be able to answer the question correctly. Okay, so I've got my equation. Again, I can't do anything with this equation yet because there's two variables. I'm only allowed to have one variable there. So I need to try and find some other piece of information. Okay, look back to the question. The sum of two positive numbers is 8. So I know that x plus y equals 8. Okay, since I have this information, I'm going to use it to substitute into here. I'm going to rearrange to get y by itself. Y equals 8 minus x, and I'll substitute y equals 8 minus x into this function. Okay, so what I'll have is s equals x cubed plus instead of writing y, I'm going to write 8 minus x. Then I need to have it in brackets because I need to show that I'm squaring everything in there. From here, I can make the function look a little bit more simple. Okay, I can do this expansion. Okay, that's just a FOIL expansion there. If you're struggling to do this in your head, feel free just to write both of these out, do the expansion, collect like terms. Okay, and then I'll make it nice and neat so that I'm ready to optimize it. Okay, I'll put them in descending power order. That's 64. Okay, from here we'll set s dash of x equals 0 or ds dx equals 0 and find those turning points, classify them, and answer the question. Some of you might be thinking, well, what would have happened if instead of rearranging for y, what if I rearranged for x? So if I instead rearrange this for x and had x equals 8 minus y, when I substitute this into where x is, I'll get s equals 8 minus y cubed plus, sorry, I'm not subbing it in there, I'm subbing it in up here, plus y squared. Okay, and I didn't do that because I've got some experience with these, and I know that I don't want to be expanding a cubic. Okay, so just think when you're rearranging this information for one variable to substitute it in, think what will be the easiest substitution, and that should guide you. Alright, so on to question 3. I don't really like the way that the textbook tries to step you through the problem. Okay, I'd probably typically just ignore these first two parts, okay, because I don't think it really helps you out in the long run. But the way I answer the question, you'll probably be able to find part A and part B anyway. Alright, a rectangular frame is to be made from a piece of wire 120 centimeters long. So I've got this piece of wire that's 120 centimeters long, and we're going to make a rectangle out of it. So we'll cut it and bend it in 3 places, okay, and it's going to transform into a rectangle. Okay, in this scenario, I'll draw a diagram of my rectangular frame, and I'll label the 2 dimensions. Just so that my answer lines up, I'm going to let the width be x, and let the length be y. So my width, I can mark it on my diagram, and the length I can also mark on my diagram. Just find the dimensions for the maximum area. So I need a formula for area. Thankfully I passed grade 6 maths, and I know that I may as well define the area as A as well, just to be formal. I know that the area is x times y. then multiply the two dimensions together, or length times width is our formula normally. And again, in this scenario, it's no good because I've got two variables. There's some more information in here though. The piece of wire is 120 centimeters long. So I know that the perimeter is 120 centimeters. Okay, here's a formula that you might not remember. The perimeter is equal to 2 times the length plus 2 times the width. I need to go around a rectangle. I go the length, the width, the length, and then the width again. To put it in terms of my actual variables, I know the perimeter is 2y plus 2x, but I also know that the perimeter is actually 120 centimeters. Because I can put 120 in here. Okay, so I've got some relationship between x and y, which I'm going to use to substitute in there. I can't substitute it in yet. I need to do a little bit of rearranging. I'm going to rearrange to get y by itself. Okay, in this scenario, it probably won't matter which way. But 120 minus 2x is 2y, and then I just need to divide both sides by 2. So y equals 60 minus x. I've actually answered part A here. It says if the width is x centimeters, show that the length is 60 minus x. Remember my length was y, here it is, 60 minus x. Right. From here, I'm going to substitute in y equals 60 minus x into a equals xy. So I'll end up with a equals x 60 minus x. And then I can do the expansion. A equals 60x minus x squared. Okay, and then I'm going to optimize this function by finding when a dash of x equals 0 or when dA dx equals 0, and then make sure I actually answer the question. For part C, I'll need to find the dimensions, so I'll need to find x and y. For part D, I'll need to find the maximum area. So once I find that x value, I'm going to substitute it into my area formula to find the area for that given width.